Hi, good morning everyone. Welcome to our Genius Maths classes, and the class is PUC first year, subject Mathematics, chapter 1, sets. Okay, this is our very first class and we are going to talking about the sets. Okay, and in this sets we are discussing about the introduction, representation of the sets, and what are the types of sets and what operations are going on the sets, and using the operation of sets we are going to explain about practical examples and some miscellaneous examples which are very important for exam purpose. Okay, now in this video we are just dealing with the introduction as well as presentation of the sets. Okay, let me know about sets and why these sets are really necessary to study. Why these sets are really necessary to study. So this is the introduction. So these sets are a fundamental part of present day mathematics. So these sets are introduction, the fundamental part of present day mathematics. So this is a fundamental part of present day mathematics, and it also helps to define the concept of relation and functions. Okay, in the next chapter we study about relation and function. Before going to study relation function, we need the concept of sets. Okay, so now sets yaduk kalibeku andre this is a fundamental part of mathematics anta ಹೇಳ್ತಾರೆ ಹೌದಾ. Next, relation and function kalibeku andre first we should know the knowledge of sets. So we should know the knowledge of sets, then we can easily understand the concept of relation and function. Okay, so these sets are necessary to study the relation of function. But how to study these sets? So it is very easiest topic. Okay, ಇದೊಂದು ತುಂಬಾ ಸರಳವಾದ ಒಂದು ಚಾಪ್ಟರ್ ಆಗಿರೋದ್ರಿಂದ ಇದನ್ನು ಈಸಿಯಾಗಿ ಕಲಿಯಬಹುದು. Okay, sets is nothing but a collection of objects. Okay, it is a collection of objects. It is a collection of objects. For example, pens, pencils, books. ಇವೆಲ್ಲ ಕನ್ಸಿಡರ್ ಮಾಡ್ರಿ. ಪೆನ್ಸ್ ಆಗಿರ್ಬೋದು, ಪೆನ್ಸಿಲ್ ಆಗಿರ್ಬೋದು, ಬುಕ್ಸ್ ಆಗಿರ್ಬೋದು, ಇವೆಲ್ಲ ಕಲೆಕ್ಷನ್. ದಿ ಆರ್ ನಥಿಂಗ್ ಬಟ್ ಅ ಕಲೆಕ್ಷನ್ ಆಫ್ ಆಬ್ಜೆಕ್ಟ್ಸ್. ಓಕೆ, ಸೊ ದೀಸ್ ಆರ್ ಕಲೆಕ್ಷನ್ ಆಫ್ ಆಬ್ಜೆಕ್ಟ್ಸ್, ಬಟ್ ದಿಸ್ ಶುಡ್ ಬಿ ವೆಲ್ ಡಿಫೈನ್ಡ್. ಇಫ್ ಐ ಸೇ ಪೆನ್ಸ್, it should consider only collection of pens only, not any other objects like pencils or books. Okay, and ನಾವು ದಿನನಿತ್ಯ ನೋಡ್ತೀವಿ ನಮ್ಮ ಮನೆ ಒಳಗೆ ಆಗಿರ್ಬೋದು, ಏನಾರು ಆಗಿರ್ಬೋದು, any materials we have bring in a groups. Okay, ಹೋಲ್ಸೇಲ್ ಅಂತ ಮಾಡ್ತಾರೆ. ಹೋಲ್ಸೇಲ್ ಅದ್ರಲ್ಲಿ ಏನು ಮಾಡ್ತಾರೆ, ದೇ ಬ್ರಿಂಗ್ ಅ bunch of materials. or ಒಂದು ಗುಂಪು ಕಲೆಕ್ಷನ್ ಅಂತ ಅವ್ರು ತೊಂಬರ್ತಾರೆ. ಹೌದಾ. ಸೊ ದೇ ಆರ್ ನಥಿಂಗ್ ಬಟ್ ದ sets. Similarly we come to know there are many concepts in mathematics. Okay, ಯಾವ ಪಾವು ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಕಾನ್ಸೆಪ್ಟು ಅದು ಸೆಟ್ ಆಗಿರೋ ಅಂದರೆ ನಾವು ಪ್ರೈಮ್ ನಂಬರ್ಸ್ ಕಲ್ತಿದ್ದೀವ. ವಾಟ್ ಆರ್ ಪ್ರೈಮ್ ನಂಬರ್ಸ್? ದ ನಂಬರ್ಸ್ which are divisors one and itself only. These are nothing but prime numbers. Okay, and number system, we have learned number system. Okay, this is also set. The natural number 1 2 3 4 5 is nothing but a set. mathematics examples. ಹೌದಾ, ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಎಕ್ಸಾಂಪಲ್ ಯಾವ ಬರ್ತವೆ? We have studied prime numbers. So these are nothing but a collection of numbers and natural numbers. This is also a collection of numbers, right? And odd and even natural numbers. So these are nothing but obtained from natural numbers only, odd and even natural numbers. Okay, so these are nothing but concepts of mathematical examples. These are nothing but example for sets. But how can you say these are set? How can you say? So what is the exact definition of set? So in order to define the concept of set, first we have to consider some example. So you have to consider some example which are set, not which are not set. So in order to define a set, which parameters are very important? Okay, let me consider some examples here. The first one is rivers of India. So rivers of India, what are the rivers of India here? So Ganga, Yamuna, Godavari, Krishna, Kaveri, Brahmaputra, etc. So these are some examples of rivers of India, right? These are some examples of rivers of India. Okay, so consider another example. The odd natural numbers, odd natural numbers below 10. Odd natural numbers below 10. So 1, 3, 5, 7, 9. So these are the numbers which are below 10. Okay, so consider these two examples here. If I say Nile river, okay, if I consider Nile river, and is this belongs to the collection of rivers of India? No, the Nile river is not a collection of rivers of India, right? So the only Ganga, Yamuna, Godavari, Krishna, Kaveri and Brahmaputra are the only rivers of India where Nile is not a river of India. That is why this doesn't belong to the set of rivers of India. Similarly, 11, if I consider 11, the odd number belongs to natural number, but it is not a part of a odd natural number below 10. Odd natural number below 10. Okay, so here we coming with a definite definition that if you consider any element, it should be in the set by well defined manner. Okay, so here rivers of India, Ganga, Yamuna, Godavari, Krishna, Kaveri, Brahmaputra, etc. are well defined within the rivers of India. Okay, if I consider Nile, which is not a river of India, okay, so using this I can easily say which are the rivers of India and which are not the rivers of India. So this set is well defined with this concept of rivers of India. With this statement rivers of India, I can easily identify the rivers of India, and Nile is not a river of India. Similarly here, odd natural numbers less than 10, 1, 3, 5, 7, 9 are the only natural numbers, odd natural numbers less than 10, whereas 11 is even, it is a odd natural number but it is not below 10. And using this I can easily say this 11 is not belonging to the odd natural numbers below 10. Okay, so now the concept comes. What is said is it is a collection of well-defined objects. It is a collection of well-defined objects. the set is a well defined object. Objects should be maintained here. Okay, let me consider some other mathematical examples. Okay, the set n is a natural numbers and z is a integers, q is a rational numbers, r is a set of real numbers. Okay, these are some sets in mathematics collection. And now I'll consider some other example, right? So what do you mean by well defined? What do you mean by well defined? Okay, I will give some statement. If I say, tell me about 5 most famous mathematician in a, okay, if I say 5 most famous mathematician in the world, and somebody says, and some people say, okay, some people say Ramanujan, okay, Ramanujan, Hardy, Euclid, Cantor, and Maxwell. So if I ask someone, if I ask the first student, he will ask about, he will tell Ramanujan, Hardy, Euclid, Cantor, Maxwell, the first person. Okay, if I ask second person, he will tell about his famous mathematician Leibniz, Newton, Ramanujan, Aryabhatta, and Bhaskaracharya. Okay, let me see here the difference. ಇಲ್ಲಿ difference ನೋಡ್ರಿ, ನಾನು ಏನು ಕೇಳಿದ್ದು 5 most famous mathematician in the world ಅಂತ ಕೇಳಿದೆ ಫಸ್ಟ್ ಸ್ಟೂಡೆಂಟ್ಗೆ. ಅವ್ರೇನು ಹೇಳ್ತಾರೆ, ರಾಮನುಜನ್, ಹಾರ್ಡಿ, ಯೂಕ್ಲಿಡ್, ಕ್ಯಾಂಟರ್ ಮತ್ತು ಮ್ಯಾಕ್ಸ್ವೆಲ್ ಅಂತ ಹೇಳ್ತಾರೆ. ಓಕೆ, ಬಟ್ ಸೆಕೆಂಡ್ ಪರ್ಸನ್ ಕೇಳಿದ್ರೆ ಅವ್ನು ನೆನಪಿರುವಂಥ 5 ಮಂದಿ ಹೆಸರು ಹೇಳ್ತಾನೆ, ಲಿಬ್ನಿಸ್, ನ್ಯೂಟನ್, ರಾಮಾನುಜನ್, ಆರ್ಯಭಟ್ಟ, ಭಾಸ್ಕರಾಚಾರ್ಯ. ಸೊ ಲೆಟ್ ಮೀ ಹಿಯರ್ clear difference between the well-defined objects. So here famous mathematician is not according as well defined, because according to the persons it will change. ಒಬ್ಬ ಪರ್ಸನ್ಗೆ ಫೇಮಸ್ ಮ್ಯಾಥಮೆಟಿಷಿಯನ್ ಹೆಸರು ಬೇರೆ ಬೇರೆ ಪ್ಯಾರಾಮೀಟರ್ ಆಗಿರ್ತವೆ. ಸೊ ದಿಸ್ ಫೇಮಸ್ ಮ್ಯಾಥಮೆಟಿಷಿಯನ್ ಈಸ್ ನಾಟ್ ಅ well defined manner of defining a sets. Okay, so with this I can conclude with the definition of set. A set is a collection of well defined objects. So here comes with the definition, a set is a collection of well defined objects. Then only we can say a set. ಇದಕ್ಕೆ ಎಕ್ಸಾಂಪಲ್ ಯಾವುದಪ್ಪ ಅಂದರೆ, ನಮಗೆಲ್ಲ ಈಸಿಯಾಗಿ ಗೊತ್ತಿರೋದು ಅಂದರೆ ಇಂಗ್ಲೀಷ್ ಅಕ್ಷರಗಳಲ್ಲಿರುವಂಥ ಓವೆಲ್ಸ್ ಯಾವಪ್ಪ ಅಂತ ಕೇಳಿದ್ರೆ ಯಾರಾದರೂ ಹೇಳ್ತಾರೆ ಎ ಇ ಐ ಒ ಯು, ಹೌದಾನೆ? ಸೊ ಓವೆಲ್ಸ್ ಇನ್ ಇಂಗ್ಲೀಷ್ ಅಲ್ಫಾಬೆಟ್, ದಟ್ ಈಸ್ ಎ ಇ ಐ ಒ ಯು. ಇದನ್ನು ಯಾರಿಗೆ ಬೇಕಾದ್ರೆ ಕೇಳ್ರಿ, ಎಷ್ಟು ಮಂದಿ ಕೇಳಿದ್ರು the same answer will come here, a e i o u. So this kind of sets, this kind of objects are called nothing but sets. Vowels in English alphabets are a e i o. This is a perfect example for defining the sets. Okay, after defining a set, and you have to think of the elements, right? And now capital letters A, B, C, D, etc. These E, B, C, D are used to denote the sets. So these capital letters A, B, C, D are used to denote the sets, and small letters A, B, C, D, E or numbers 1, 2, 3 etc. are used to denote the set. So this is very simple. If you define any set and A, B, C, D, for example, A, E, I, O, U. Here, this A is representing a set. This is capital A representing a set, and the small letters A, E, I, O, U are representing elements. This is very simple concept. Okay, and now using epsilon, Greek word epsilon, I can say that either the element belonging to the set or not belonging to the set. So A belongs to A. We can read it as A belongs to A. A belongs to A. So if element ಯಾವುದೋ ಎಲಿಮೆಂಟ್ ಈ ಸೆಟ್ಗೆ ಸೇರಿದೆ ಅಥವಾ ಈ ಸೆಟ್ ಒಳಗೆ ಇದೆ ಅಂದ್ರೆ ಅದನ್ನ ಹೆಂಗೆ ಗುರುತಿಸ್ತಾರೆ ಅಂದರೆ A belongs to A. We can read it as A belongs to A. If the set doesn't belongs to A, we read it as A. So B does not belongs to A. So this is a simple concept. If the set belonging to the A, we write like this. If the set doesn't belong to the A, we write like this. Okay, this is a very simple concept. And now we are going to represent sets in 3 methods. So there are 3 methods in representing sets. There are 3 methods in representing a set. One is roster method, roster or tabular method. Second one, set builder method, set builder method or rule method. And third one is Venn diagram. So these 3 are 3 methods in representing a set. Okay, let me discuss about set 1, roster method. Okay, in this roster method we define the elements. In this roster method we define the elements, or we listed the elements and separating by commas, and also they are enclosed in braces, pair of braces. So in this method all the elements of set are listed and separated by commas. Okay, and enclosed within pair of braces. So these are nothing but braces. Example 1, 3, 5, 7, 9. So I am defining the elements, odd natural numbers less than 10, 1, 3, 5, 7, 9, which are listed and they are separated by commas and they are enclosed within a pair of braces. So this is a roster method. And second one is set builder method. So what we write in roster method, we have to give some rules for this. And that is nothing but a set builder method. That means all the elements of the sets possess a single common property. In this method all the elements possess a single common property. So let me consider above example 13579 x such that x belongs to n and x is less than or equal to 10. x less or equal to 10 and x is a odd natural number. X is a odd natural number. Consider 1, 3, 5, 7, 9. So this x belongs to natural number and x is also less than 10 and x is a odd natural numbers. What are the numbers here? 1, 3, 5, 7, 9. So this possesses a single common property. This is an odd natural number and less than 10 and it should belongs to natural numbers. So this is a common property among all the elements. And third one is Venn diagram. Venn diagram. It is very simple. What are the elements we have written? You have to represent in a diagrammatical way. You have to represent in a diagrammatical way. So I am writing A, E, I, O, U in a diagram. In a diagrammatical way. So this Venn diagram helps to represent sets in a relations. Okay. So these three are the three methods representing sets. So ಈ ಮೂರು ಮೆಥಡ್ ಏನದಾವಲ್ಲ ಒಂದು ಯಾವುದೇ ಸೆಟ್ ಅನ್ನು represent ಮಾಡುವಂತ ಮೂರು ಮೆಥಡ್ಗಳು. Okay. Let me consider some examples. Okay. We consider some example. The very first example is first example, write the solution of the x equation. First example, write the solution set of the equation x square plus x minus 2 equal to 0 in roster form. So equation ಏನಿದೆಯಲ್ಲ ಅದು set builder form ಒಳಗಿದೆ. ಅದನ್ನ ನಾವು ಏನು ಮಾಡಬೇಕು ಅಂದ್ರೆ roster form ಒಳಗೆ ಬರಿಬೇಕು. ಹೌದಾ? So its solution is, consider the equation. Consider this equation x square plus x minus 2 equal to 0. Okay. So see, observe this equation. It is in the quadratic equation. Yes, this is nothing but a quadratic equation. This is quadratic equation. So we know ನಮ್ಗೆ ಗೊತ್ತಿದೆ quadratic equation ಹೆಂಗೆ ಸಾಲ್ವ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿ, because they ask the solution set. Solution set is nothing but the roots. Okay. ಒಂದು Sridhar method, ಇನ್ನೊಂದು factorization method. The very simple way is factorization method, right? So x square plus x minus 2 equal to 0. It can be written as splitted x square plus 2x minus x minus 2 equal to 0. ಹೌದಾ? ಇದನ್ನು ಹಿಂಗೆ ಸ್ಪ್ಲಿಟ್ ಮಾಡಿಬಿಡ್ತೀವಿ. ನೆಕ್ಸ್ಟ್ ಕಾಮನ್ x plus 2 minus x plus 2. ಹೌದಾ? ಇಲ್ಲೂ ಕಾಮನ್ x ಇದೆ, ಇಲ್ಲೂ ಕಾಮನ್ minus 1 ಇದೆ. ಹೌದಾ? So x into x plus 2 minus 1 into x plus 2. So ಇಲ್ಲಿ ಎರಡೂ ಕಾಮನ್ x plus 2 and again x minus 1. So its root ಏನದು x equal to minus 2 one root and x equal to 1 is another root. So they asked, ಏನು ಕೇಳಿದಪ್ಪ? They asked the solution set. So if I ask a solution set, then what are the elements of the set in roster form? That is minus 2 1. So the solution set of the given equation can be written in a roster form minus 2 1. So this is the solution of the first example. Let me consider the second example. Write the set x. Write the set x such that x is a positive integer and x square is less than 40 in the roster form. So they are also given in a set builder form. The given set is in a set builder form and we have to write it in a roster form. That is nothing but we have to write the elements. ಈ ಕೊಟ್ಟಿರುವಂತಹ ಸಿಂಗಲ್ ಕಾಮನ್ ಪ್ರಾಪರ್ಟಿ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನಾವು ಅದರ ಎಲಿಮೆಂಟ್ ಕಂಡು ಹಿಡಿದು ಅದನ್ನು ರೋಸ್ಟರ್ ಫಾರ್ಮ್ ಒಳಗೆ ಬರೆಯೋದಕ್ಕೆ ರೋಸ್ಟರ್ ಫಾರ್ಮ್ ಒಳಗೆ ಬರೆಯೋದು ಸೊಲ್ಯೂಷನ್. ಓಕೆ. ಕನ್ಸಿಡರ್ ದಿಸ್ ಆಸ್ x is a positive integer, right? X is a positive integer and this x square is less than 40. ಯಾವ ಬರ್ತಾವಪ್ಪ? ದಿಸ್ x square less than 40 ಬರುವಂಥ ನಂಬರ್ಸ್ ಯಾವುದಾವ? ಪಾಸಿಟಿವ್ ಇಂಟೀಜರ್ಸ್ ಯಾವಿದಾವೆ? ಹೌದಾ? Positive integers, they are only asked about positive integer starts from 1, right? So consider 1 square ಮಾಡಿದ್ರೆ ಎಷ್ಟು ಬರುತ್ತೆ? 1 ಬರುತ್ತಾ? So this 1 is less than 40. So 1 is the element of the set. Second, 2 equal to 2 square. 2 square equal to 4 and the 4 is less than 40. This is the second element of the set. See, 3 square equal to 9, and 9 is also less than 40. Therefore 3 is also an element of a set. And 4 square equal to 16, and this 16 is less than 40, and therefore 4 is also an element of the set. 5 5 square equal to 25, less than 40, therefore 25 is also an element of the set. 6 square equal to 36, which is less than 40, and therefore 6 is also an element of the set. 7 square equal to 49, which is greater than 40, and therefore 7 is not a member of the set. 7 is not a member of the set. Therefore 1 2 3 4 5 6 are the only elements of the set. Only elements of the sets. Okay. And again we have considered one more example. Here the elements of the sets are in a roster form, and we have to write it in a set builder method. Example: write the set A 1 4 9 16 25 etc., and you have to write this set in a set builder method. Solution is: consider A 1 4 9 16 25. Okay, 1 4 9 16 25 are written in a roster method. Okay, observe this. Observe ಮಾಡ್ರಿ 1 4 9 16 25. You ನೋಡಿದ್ರೆ ಏನಿಸುತ್ತೆ? These are nothing but the squares of natural number. Squares of natural number, that is nothing but 1 square equal to 1. Okay, this is square of natural number. And 4 can be 2 square, so belongs to natural number. And 9 is the 3 square equal to 9, belongs to natural number. And 16, which is 4 square, belongs to natural number, right? So by observing this, these are the squares of natural numbers, and therefore we write in a set builder form A such that x is a natural number and x equal to n square, where n belongs to n. This is the rule for defining the elements of the set. Or A equal to ex such that ex equal to n square and n belongs to n. So this completes the solution, and with this we come to know we can easily write roster form in a set builder method and set builder method in a roster form. This is the advantage of writing the sets. Okay, with this I conclude my chapter, and if there any doubt, you can comment in a comment box. Okay, so let me stop here. In the next chapter, in the next class, I will going to explain about types of sets. Okay, so types of sets are very important. It will help in many concepts like relations and functions. And one more question is, why we need to study sets? Why we need to study sets? If you know the answer, just comment in a comment box. Thank you so much.